So this project is looking at A star and Q learning for the sake of the first run. I'll turn it to deterministic, and also down here I'm going to turn it off for random. So let's go ahead and give it a run and see what happens. So it'll look through from the start state, which is better on the bottom left, and the bottom right is the closed state. Green are the explored states, the closed states, and then the blue is the open list states. And so up here you see the F values and then the G and H values down there. The value on the left, say 7, that's the distance from the start to there, and then 12 is the Manhattan distance to the goal state. So now let's turn it to a random grid. So down here we'll turn it to true, go ahead and run, and then it just sets up a random grid, and then we can run this again just to see that it gets another random grid, and it'll get to the end. So then now let's make it stochastic. So we'll turn this random onto false just so we can see the original grid, and then we can say is stochastic to true. And then what it does is every iteration, the robot per se, inches closer to the goal. So you'll see the original state here, it's moving pretty fast, but the original state will move along the line until it gets to the goal. So as you see, it's getting faster and faster, it's getting closer. So it has a 10% chance of staying where it's at, a 10% chance of randomly going in another direction, and a total of, I think, 50% chance of actually going in the direction it was intended. And then once it gets here near the end, it just turns blue saying, hey, we reached the goal. So then for the last test, we'll do that with a random layout. Set random to true. And then this is just, it's exploring the entirety of the grid. And see, in this particular example, there's a lot of obstacles and a lot of potential routes that could make it to the goal until it finds that barrier. And so as it gets closer and closer, it realizes that the top route around the top is the right way to go. And that's that. So now we'll go on to Q learning. Alright, so I'm talking about the Q learning portion now. And essentially the algorithm is presented here inside my pseudocode. And what it essentially does is it takes in an action and a state and updates it based upon some learning, some rewards that are given, some future predictions of reward, and a discount factor that degrades the reward being returned over time. And I can kind of show that with the actual program running here. So it does, it starts here in the bottom left, and as you can see, it's trying to learn right now as it's running through. So it starts here in the bottom left, and then it moves all the way to this bottom right square over here, which is the reward or the goal. And so what it does is it randomly is choosing directions, and you can see the reward based upon that direction on the top, left, right, and bottom. And then once it gets to that point, it's allocated a percentage of that reward that's degraded to the start point. And then once it reaches around 250 over here, I'll run through the actual training rounds and then see what the result is. So I'm at the point where I have the heat map generated for this algorithm. So what I'm going to do is I want to press C here, and it's going to generate a random start location somewhere on this axis right here, this column. And then based upon that, it will then traverse to the goal. So we'll give it a shot, push C, enter. And it's traversing through and found the goal. And then here's a second round because it asked for 2. So here's the second random start point, which was 2 cells below the original, and here it is traversing through to the end as well. Okay.